Jai Hind to all. Myself Akanksha Shukla. I am working as an assistant professor in IT department in Akgec Engineering College. Today I am going to discuss one of the topic that is very much useful in data analytics, or we can say that in machine learning broadly, if we can say, that is regression versus classification. So basically both these algorithms are supervised learning algorithms and used for prediction in machine learning, and both the algorithms are working with the help of labeled data set. What is the main or what is the basic difference between these two algorithms? That regression algorithms are used to predict the continuous values, or classification algorithms are used to predict or classify the discrete values. So what is the difference between these two values, that is continuous or discrete? So continuous values are those values which have continuity, just like price, salary, age. So for this particular kind of examples, we are having the regression algorithm if you are going to predict that kind of values. And if you are going to predict or classify the discrete values, just like male, female, spam, not spam, true, false, yes, no. So for classifying these discrete values, we have a classification algorithm. So this is the basic difference between regression and classification algorithms, that regression basically focuses upon the continuous values and classification basically focuses upon the discrete values, which have two options only, yes, no, 0, 1, male, female, true, false, means whatever, whosoever example if you have given, and if you have to classify on the basis of discrete values, then we have a classification approach only. So this is the basically diagrammatic representation of classification versus regression. So here in classification we have only two options, that is green or dark green, or sea green or green color, and in regression we have dots, same dots, okay, means here we have a continuity of the values, okay, and here we have only two dots, two colored dots, and on the basis of that we are going to classify the data. So what is classification? Basically classification is a process in which we are going to find a function which helps to divide the data set into the classes based on different parameters. So if a computer program is trained on the training data set, and based upon that training it is going to categorize the data into different classes, then the task of the classification algorithm is only to find the mapping function to map the particular output, to map the particular input to that particular discrete output, which is y, and the input is considered as a x. So the task of the classification algorithm is to find mapping function to map this particular input to the discrete output, that is y. For example, to understand the classification problem, the best known example is email spam detection. So model is trained on the basis of millions of emails on different parameters, and whenever it receives a new email, then it identifies immediately that whether that particular email is spam or not. So if the email is spam, then it is moved to the spam folder, otherwise it is moved towards the inbox folder. What are the types of classification algorithms? Basically classification algorithms can be divided into following types: logistic regression, k nearest neighbors, SVM, kernel Bayesian, naive Bayes decision tree, and random forest classification. So out of these particular types, well known is k nearest neighbor, SVM, naive Bayes decision tree, and in nowadays random forest classification is also useful when we are going to use the ensemble learning modeling in machine learning, okay. So if we talk about the SVM, then support vector machine, what is basic purpose of using SVM? SVM works well for small data sets, and it basically classifies the data by using the hyperplane, okay. So in SVM what we have a hyperplane, and the points which are going to lie on that particular hyperplane, then that particular point is considered as a support vectors in the SVM. I am going to give you a little view about all these classification algorithms, not in detail. What is Bayesian classification or Bayes theorem? Basically Bayes theorem also identifies the probability of the occurrence of a particular event with respect to the occurrence of another event. Decision tree classification works upon tree-like structure, and based upon the decision that whether we have to move further or not. If yes, then move to the another step, otherwise have another alternative. Suppose if you want to, if an employee has to join a company, then what are the parameters which could be taken into the consideration? So first basic parameter is a salary. If salary is as per his or her expectation, then he will opt to that particular company. Another parameter, that whether the cab facility is provided or not. Another, that whether it is nearest to its home location or not. So these are the some parameters which can be taken into the consideration and which can be used for further decision tree classification. In random forest classification, what happens? Basically, it is a collection of so many decision trees that combines and form the random forest. So this is a little bit clarification about the classification algorithms. What is regression? Regression is a process of finding the correlation between dependent and independent variables. So basically it helps in predicting the continuous values, just like prediction of the market trends, prediction of the house prices, prediction of the age, prediction of the incomes. So basically it is used for predicting the continuous variables. So task of the regression algorithm is similar, just like classification algorithm. It also find the mapping function to map the input variable to the continuous output variable, whereas classification maps the input variable to the discrete output variable, that is y. Now taken the example of regression, suppose we want to do the weather forecast. So what we do, we use regression algorithm. So in weather prediction, the model is basically trained upon the past data, and once the training is completed, then it can easily predict the weather for future days also. So what happens in prediction based modeling, that we have a data set and we trained that particular data set which is taken from the past experiences, and we trained that particular data set. And when a new data item appears or occurs, then what we do, we use the same particular trained model on that particular new item set, and then we have a testing phase that we predict the weather for a future days also based upon that particular pre-trained model. Just like classification algorithms, regression algorithms have also different types, just like support vector regression, decision tree regression, also random forest regression, also polynomial regression, multiple linear and simple linear regression. Okay, so in simple linear regression we have only one dependent or one independent variable, and in multiple linear regression what we have so many independent variables. Just like if you want to predict the crop yield, then there are so many independent variables which are directly responsible for that particular dependent variable, that just like weather, soil quality, so rain. So these are the some different parameters which are basically dependent upon the dependent variable. So now what is the difference between regression and classification? So basically what happens in regression, the output variable must be a continuous nature or it must be a real value. What happens in classification, the output variable must be a discrete variable. For example, which I had given earlier also, that it must have two values, yes, no, male, female, true, false, spam, not spam. So whenever these kind of things came into the consideration, then we must have a classification algorithm to clarify these kinds of problems. What is the task of the regression algorithm? Basically, the task of the regression algorithm is to map the input value x within the continuous output variable, which is y. And contrast in classification algorithm, it is used to map the input value x with the discrete output variable, that is y. So in these two examples, in these 2 points, what we have seen, that basically in regression, what happens, the output variable must be of continuous nature, and in classification the output variable must be of discrete value. So when the mapping function which is used in regression and classification algorithm both, that particular mapping function maps the input value to the continuous output variable, and in classification the mapping function maps the input value with the discrete output variable. So this is the basic fundamental, that mapping function suppose fm is the mapping function, so it maps the input variable or input value, sorry, we can say input value, that is x, and output is continuous in case of regression and discrete in case of classification. Okay. Regression algorithms are used with the continuous data, just like example or graph we have seen, just like continuous data, just like prediction of prices, prediction of disease, prediction of house prices, prediction of sale, prediction of weather, prediction of frequent item sets, we can say. Okay, so for predicting the continuous values or data, we have regression algorithm, and in regression we always try to find the best fit line which can predict the output more accurately. So what is the best fit line that can predict the output more accurately? What is the equation of line? Y is equal to mx plus c. So in regression basically we focuses upon to finding the best fit line which can predict the output in a more accurate manner. What happens in classification? Basically in classification, the classification algorithms are used with the discrete data. So in classification we always try to find the decision boundary that can best divide the data set into different classes, just like in the graph which we have seen earlier. So this is the hyperplane, or we can say this is the decision boundary which is going to divide the data set into the different classes. Okay, that whether this particular data set lies in first class or this particular lies in second class. So basically classification focuses upon finding the decision boundary which can better divide the data set into the different classes, and in regression we are going to find the best fit line which can predict the output more accurately. Now what are the basic problems which we are going to solve by using the regression algorithms? So regression algorithms can be used to solve the regression problems. Problems are just like weather prediction, weather forecasting, house price prediction, protein secondary structure predictions also. Okay, so when we are having a continuous data set, or when we are going to predict that continuous data, then we are having the regression algorithm and we have to use that particular regression algorithm. Depending upon the data set, we have a different regression algorithm, just like simple linear regression, multiple linear regression, or polynomial regression, or we have to use SVM decision tree or random forest regression. So depend upon the problem or depending upon the data set, we choose that which kind of regression algorithm we are going to suppose to use in that particular case. Just like classification algorithms also, we have several classification problems, just like identification of spam emails, speech recognition, identification of the cancer cells. Okay, that whether the particular cancer cell is present or not, whether the protein secondary structure labels are helix or coil. So these are the different problems in which we have a classification algorithm. Similarly, just like regression algorithms, we are also having different kinds of classification algorithms, just like k nearest neighbor, SVM, kernel SVM, random forest classification, decision tree classification. So depending upon the data set or depending upon the problem, we have a choice that which kind of classification algorithm is better suited for that particular problem. So depending upon the data set and depending upon the problem, we have a choice that which particular algorithm we use in that particular case. So regression algorithm can be further divided into linear and non-linear regression, and the classification algorithm can be divided into a binary classifier and a multi-class classifier. So if we have only two classification or two division, just like in that particular example, that spam or not spam, cancer cell, identification of cancer cell, that present or not present. So these are having two classification. So that problems will be solved by using binary classifier only. But if you are having a protein secondary structure prediction, so in which we have a three labels, secondary structure labels are three, HEC. So in this we have to classify the problem, or we have to classify the data set, or classify the input into three classes. So in this particular cases, we do not have a binary classifier. We do not mean, we can't say that we do not have a binary classifier. We can use binary classifier, but multi-class classifier will be better suited for these kind of problems, because we have a three variations. We have a three variations for a particular input. So in that particular cases, in spite of using binary classifier, we must have to use multi-class classifier, because multi-class classifier is have better understanding, or it better classifies the data comparatively to binary classifier. So on a summary note, we can say that basically regression algorithms can be used to map the input function to the continuous output variable, and classification maps the input value to a discrete variable. Regression algorithms can solve the problem just like weather prediction for a house price, sales prediction, disease prediction, cancer cell predictions also. Okay, so these examples can be considered inside the regression problems. What about classification? It can have the problem just like identification of a spam emails, speech recognition, identification of cancer cells, secondary structure prediction, okay, secondary structure label classification. So these are the basic examples. Regression algorithm can be divided into linear and non-linear regression, and classification have variations or can be divided into binary or multi-class classifiers. So this is the basic definition between regression and classification algorithm. That's all for this particular topic, that is regression versus classification. Thank you.